Unit 1A, Lesson 5. There's one standard with two parts that we need to discuss. Interpret expressions that represent a quantity in terms of its context. Part A, interpret parts of an expression, such as terms, factors, and coefficients. Part B, interpret complicated expressions by viewing one or more of their parts as a single entity. For example, interpret P times a quantity 1 plus R raised to the N as a product of P and a factor not depending on P. There are 6 vocabulary terms that you need to be aware of or familiar with in this lesson. The first one is terms. Terms are numbers or variables that are separated by addition or subtraction signs. Next one is coefficients. Coefficients are values that are being multiplied in front of a variable. Standard form is listing terms in descending order, highest degree to lowest degree. Then we have factors. Factors are values, quantities being multiplied together. The degree, you can have the degree of a term, or we can have the degree of a polynomial, and that's referring to the highest exponent value. And then the sixth one, the leading coefficient. That is the coefficient, the quantity being multiplied in front of the highest degree term. Alright, so 6 different terms. We're going to go through these more in depth once we start going through examples. Now we are going to work on naming polynomial expressions by the degree and the number of terms. So if you look in the middle, the first example, the first polynomial we have is 5. Technically, this could be the same as 5 times x raised to the 0 power. We know anything raised to the 0 power is 1, so x to the 0 power is 1. 1 times 5 is just 5, so we save time by not writing in this part. That is why if you have a constant, just a number, the degree is 0. Okay, we still have an exponent value. That exponent value is 0. So the degree is 0. We name a degree of 0 as a constant. Here we have no addition or subtraction signs. There is only one term. If you have one term, we're going to call that a monomial. Mono means one. Nomial means terms, so one term. Next we have x plus 4. So if we look at the degree, the exponent on our variable is going to be 1. If it's not written in, it's understood to be 1. So if the degree is 1, we call that a linear function. If we look, we have one addition sign separating two terms. If we have two terms, we're going to call that a binomial. Bi means 2, nomial means terms, 2 terms. Now we have 4x squared. The exponent value, the degree is 2. We call that a quadratic. There's no addition or subtraction signs. There's only one term. We call that a monomial. Fourth example, 4x cubed minus 2x squared plus x. If we look at the highest degree, it is 3. So we're going to call that a cubic function. The number of terms, there's one subtraction and one addition, which separates 3 terms. We call that a trinomial. This would also be written in standard form because we're going from the highest degree 3 down to a degree of 2 down to a degree of 1. So descending order by degree, this would be written in standard form. Fifth example, we have 2x to the 4th plus 5x squared. Highest degree is 4. We're going to call that a quartic. There's only 2 terms, so it is a binomial. And the last one, we have negative x to the 5th plus 4x squared plus 2x plus 1. Highest degree is 5. We call that quintic. We really don't work with this too often. Normally the highest we're going to go is 4, but we can be familiar with this. Quintic is a degree of 5. We have 3 addition signs separating 4 terms. If you have 4 or more terms, we're just going to call that a polynomial. So working on naming polynomials by the degree and the number of terms. In the next example, we want to identify the degree, number of terms, standard form, leading coefficient, and name for each of the following polynomials. First polynomial we have is 4x squared minus 2x cubed plus 7. The easiest thing to do is first write each polynomial in standard form. It's going to be easier to identify the degree and leading coefficient. Standard form is going from highest degree to lowest degree. So our highest degree term is negative 2x cubed, so we need to write that first. Negative 2x cubed. The next highest degree is the x squared, so we have plus 4x squared plus 7 at the end. Going from highest degree to lowest degree, degree referring to the exponents, this is written in standard form. Now we want to identify the other four parts: the degree, the number of terms, the leading coefficient, and the name. The degree, we just have to look at the first term, which is 3. The number of terms we're looking, we have 1 term, 2 terms, 3 terms. The leading coefficient is the coefficient in front of the highest degree term. If we have this written in standard form, we know the highest degree term is written first, so the leading coefficient is negative 2. And now we want to name this by the degree and the number of terms. If we're naming this by the degree, it's 3. We call that a cubic. And now we want to look at the number of terms. We said we have 3 terms. If we have 3 terms, we call that a trinomial. So we would name this polynomial as a cubic trinomial. First thing, write it in standard form. Makes it easier to identify the remaining parts. Another example of identifying the degree, number of terms, writing it in standard form, identifying the leading coefficient, and then naming the following polynomial. First thing, need to write this in standard form, highest degree to lowest degree. If we look, the highest degree is 4, so we need to write that term first. 7x to the 4th. The next highest degree is 2, minus 2x squared, minus 13x plus 8. Now we have it in descending order. It's in standard form. It's going to make it easier to identify the degree and the number of terms, leading coefficient, all that stuff. Now if we go back, the degree, the highest exponent is 4. The number of terms, there's 2 subtraction signs and 1 addition, which creates 4 separate terms. The leading coefficient, the number in front of our highest degree term, when it's in standard form, that will be our first coefficient, is 7. And now we need to name this first by degree. If it's a degree 4, that is a quartic. Now we look at the number of terms. There's 4 terms. I said before, if we have 4 or more terms, we are just going to call this a polynomial. So naming this polynomial, it's a quartic polynomial. First, write it in standard form, then we can identify the degree, number of terms, the leading coefficient, and name it. Now we're going to look at a few more complicated expressions. The first one is 5x minus the quantity 2 minus 4y. What we're looking at in this problem, we need to determine how many terms there are in this expression. So looking at that initially, many of you probably want to think there are 3 terms, okay, and that would be incorrect. If we look, we have 1 term which is 5x, we have our subtraction sign. Since we have a set of parentheses, we're treating that as one quantity, one entity. Alright, so whenever you see parentheses, we're thinking of that as one whole thing. So in that expression, we actually only have 2 terms. Now if we look at the one down below, we have p times the quantity of 1 plus r raised to the n. This is actually your compound interest formula. We'll work more with that later on. We've discussed that in Algebra 1 though. We want to determine how many terms there are in this expression. Okay. We see there is 1 addition sign, but that is inside a set of parentheses. The p is being multiplied by that quantity, P stands for the principal, there is actually only one term. This is one whole entity. We have a set of parentheses. We're treating this as one thing being multiplied by another value. There's one term. Also in this expression, we want to determine how many factors there are. How many things are being multiplied? Well, we said inside the parentheses, we're treating that as one factor. And we have the P being multiplied outside. That is another factor. So we have two things being multiplied, two entities being multiplied, two factors. You need to make sure you understand how parentheses affect how we look at terms and factors. Whenever we have a set of parentheses inside there, we're treating that as one whole thing. To end this lesson, we're going to use ideas of quadratic factoring to factor each of the polynomial expressions. Off to the side for this first one, I'm going to write x squared minus 13x plus 36. We're just going to quickly review how we would factor this quadratic expression. We need to look for factors of 36 that when we add together give us a negative 13. So if this is a positive constant, we know both our factors have to be negative. Well, negative 9 times negative 4 is positive 36. Negative 9 plus negative 4 is negative 13. This will factor into x minus 9 times x minus 4. So back to our original, we have x to the fourth minus 13x squared plus 36. We are going to treat this the same way, except rather than have x plus or minus a number, we are going to have x squared. This will factor into x squared minus 9 and x squared minus 4. Now we're not done, because if you look at both of these factors, x squared minus 9, this is a difference of squares, and x squared minus 4 is a difference of squares as well, so we can break each of those down. If we break down x squared minus 9, that factors into x minus 3 times x plus 3. And if we look at x squared minus 4, that factors down into x minus 2 times x plus 2. So using ideas of quadratic factoring on a quartic expression, breaking it down. The last one, we have x to the fifth minus 5x cubed plus 4x. Think back to when we discussed factoring. One of the first things you should look at, what do all of the terms have in common, if anything? If all the terms have something in common, we need to factor that out in front. So if you look at all three of these terms, x to the fifth, 5x cubed, 4x, they all have a factor of x in common, so we can bring that factor out in front, which will leave us with x to the fourth minus 5x squared plus 4. Now we have a quartic. We're going to use ideas of quadratic factoring to break this down further. So we have our factor of x. We have x to the fourth minus 5x squared plus 4. We're looking for factors of 4 that when we add together give us a negative 5. Okay? So again, since this is positive and our b value is negative, we know both factors must be negative. Negative 4 times negative 1 is positive 4. Negative 4 plus negative 1 is negative 5. This is going to factor into x squared minus 4 times x squared minus 1. Again, if you look at x squared minus 4 and x squared minus 1, those are both difference of squares, so we can break those down even more. We're left with x squared minus 4, we factor down into x minus 2 times x plus 2. X squared minus 1, we factor that down into x minus 1 times x plus 1. Using ideas of factoring out a monomial, what all those terms have in common, then using quadratic factoring ideas to break down a quartic expression, and then breaking down a difference of squares expression. The main focus of this lesson was to look at an expression, write it in standard form, identify the degree, the number of terms, the leading coefficient, and being able to name that expression by the number of terms and the degree. We also looked at more complicated expressions, seeing how parentheses affect that expression. Okay, if we have some quantity inside parentheses, we're treating that as one entity. That will affect how many terms and how many factors we have in that expression.